We will start a bit. We will start by talking a bit about K6, which is the company that I work for, and performance engineering and load testing in general, and about the key performance indicators of a tool in this category that K6 is. Mainly for a tool like K6, which is a load testing tool or a performance testing tool, it all comes down to speed, scalability, scriptability, and ease of use. And we will then continue by looking into why we chose Go for our project and in what way that correlates to the KPIs that we mentioned earlier, that is performance, ease of use, etc. And what are the differences between using compiled languages in contrast to interpreted ones that is running, for instance, in a virtual machine? And I mean, things like memory footprint, disk usage, or CPU utilization, they all factor into this. While compiled languages like Go have the advantage of excelling in all of these areas, they lack the flexibility that an interpreted or scripted language provide. And to solve this, we wanted to add some kind of embedded scripting layer, allowing for the user to write their own code in something other than Go to modify the behavior of our application. And we will have a look at a few of the alternatives here available, like Goja, but also Otto and V8 and some others. We will at least mention them. And just going back a bit, as I said, I'm a developer advocate at K6, and my mission is to help developers succeed by testing better as well as writing better tests. And for the last couple of years, I've mostly been focusing on the performance and reliability space. And if you want to get in touch with me after this talk, you can find me on Twitter, where I'm 0x12b. And let's talk a little bit more about K6 before we start. It's an open source reliability testing tool written in Go, and it's currently aimed towards performance testing. And for tools in this category, as I mentioned, scalability and speed are extremely important, as it's supposed to generate real-world traffic volumes while still requiring as little hardware as possible. For instance, on my machine that I'm currently using, I can simulate over 200 concurrent virtual users accessing an API or a website. And for a decent desktop computer, like the ones you might be using or that many have at home, you can get up in the number of thousands or even 10,000s. And this would not even be remotely possible using a regular browser, which has to concern itself with a lot of other stuff, like rendering a DOM or executing client-side scripts sent by the server. And with the whole client or load generator written in Go, it's a much smoother and performant experience to do this. We can utilize powerful concurrency primitives like channels or Go routines out of the box, making scaling out a bit much more pleasant experience than in most other languages. This, however, is not the only reason for Go being such a great choice for this type of software. I mean, the complexity of Go code or Go code is generally fairly low, and it's quite easy for someone with some experience in Go to quickly be onboarded onto a new project, since there are so powerful ways, or rather powerful tooling available that forces you into one direction or using one style when you write your code. And for open source projects like ours, that's really great, as it unlocks the potential for having external contributors that might not even have written Go before. They can look at the code, and in a bit. It might differ from person to person, but in an hour or 2 hours, they probably have a fair sense of what is going on, even if they don't have that much Go experience previously. And at the same time, given the concurrency primitives and that it isn't a scripted language, the performance is, if not top-notch, then at least way above average. But one thing that Go lacks, though, as I also mentioned, is the flexibility of interpreted languages. In a typical interpreted language like Python, JavaScript, or Bash, changing the behavior of an application to fit your specific needs is quite simple. I mean, you could just go ahead and modify the script and run the code again. No build or compilation is really needed, as the source code in those cases mainly are the application. And for applications where it's important that the user is able to modify the behavior of the application to fit their use case, a typical Go application might end up either with huge declarative configurations, as you might have seen if you've ever touched Kubernetes, or with some kind of GUI or a bespoke domain-specific language that the user needs to learn to be productive. And with this in mind, is there any way we can increase the flexibility? I've already hinted in the title that there is, but how do we go about doing it? Allowing the users to define their own behavior as part of the application without sacrificing too much of the speed and simplicity of Go. We could build a GUI. This would probably be the easiest option, the option that most take. You build a GUI and you put out controls that allows the user to modify the application logic in a way they see fit. But in our case, on K6, we wanted to cater towards development teams, and we wanted to find a solution that fit nicely into their everyday workflow. So instead, I'd argue that one of the better and most obvious solutions maybe would be to embed a scripting language that exists already within Go, keeping the core pure Go while allowing us to script the behavior using the core as building blocks, kind of like Lego, I guess. And if we do this, what are our options really? So we had a huge question mark to straighten out. What scripting language would be the most appropriate? There are multiple options available. We could use Lua, Python, JavaScript, or even interpreted Go using a project like Yagi. And all of these projects or options come with their own pros and cons. But for us, aside from the performance, as I mentioned, onboarding was a very important aspect. And what language would be more widely known than JavaScript? Or at least that's how we reasoned. So we decided to go for JavaScript. And with that decision, we still had multiple options to pick from. We could, for instance, use a V8 wrapper, or we could use a project called Otto, or we could use Goja. And as always, they all came with their own pros and cons. And with K6, we initially went with the project Otto, which was a huge improvement over the previous Lua scripting layer that was available in our previous tool, mainly because of the commonality of JavaScript and its ease of use. But after a while, though, the maintainer of the project of Otto actually got in touch with us and suggested that Goja might be a better fit because it's much faster in most common use cases. And it turned out that recommendation was really well deserved. It proved to be about 7 to 10 times faster for most common use cases. So just by switching the library we used for embedding this scripting layer, we got a 7 to 10 times performance increase in the application. And of course, here one might ask why we didn't go with the V8 bindings instead, given that V8 is so popular and quite feature complete, probably the most feature complete engine for JavaScript. In our case, we needed something that was fast, really fast, even when using thousands of parallel runtimes. and didn't complicate usage too much by adding a lot of external dependencies and prerequisites that the user had to cater for themselves before being able to use our application. Many of you have probably used Java at some point and probably also cursed at having to set up the Java path and things like that and making it work nice with the development kit or with the runtime. And we wanted none of that in our product or our project. And V8, which uses CGO, that is C bindings for Go, also adds quite a bit of overhead when you scale your runtimes this way that we do. For instance, if you're running 50 V8 runtimes in parallel, that would actually require CGO to keep 50 plus OS threads going as well, as it has no way of really knowing whether they would block or not when you make a call to them. Imagine this if we scale that up to our use case and we have maybe 1,000 users or runtimes, or maybe even tens of thousands of runtimes. That quickly becomes a real resource hog just to orchestrate that many OS threads. And as I said, it would also require our users to actually install or build V8. So we opted for Goja in the end. And now it's time for a short demo where I will show how Goja works, or rather how we can get started with Goja quickly and get up and running. Let me just change my screen share. All right. And I've prepared a bit, so I set up a Go modules file, and I've just created an empty main file just so that we wouldn't have to go through that hassle. So we're going to start by declaring our package. And we'll then do a main function that will be where we enter when we run our application. And we're going to just go ahead and directly initiate a new instance or a new virtual machine for Goja. As well as importing that package. All right. And we then will create a console object, which we'll use to simulate the console object that you usually find in a JavaScript environment. I'm going to make sure to share these after the conference. So if you want to try it out yourself or elaborate on it, you'll be able to just knock yourself out. OK, so we have a type called console, which is a struct. And we also created a factory or a new function for creating instances of that struct. And when we create a new console struct, we'll also tell Goja that this is a new object, or we'll add a new object, JavaScript object to it. And we'll then set the method log to point towards a Go native log function, which we'll also define. So on our instance of console, we have the function log, which takes a string and then prints it out using the format package. Also add format here. And return our newly created console. OK, so we now have a way to create new console objects that will add to this Goja runtime that we'll be providing to our users. So once we have that done, we'll go ahead and make a new instance of that or a new struct of that and pass it the newly created Goja VM. We'll then set the object console in the global scope of that VM to actually point towards our struct. And then we'll try it out by running a string, which will be an embedded JavaScript. But if you do this in a real application, you would probably have some way for the user to point at a JavaScript file and have that be loaded instead. But for the case of simplicity for this demo, we'll just do the run string and give it a static string. So now we're writing JavaScript. We want the function say hello to call console log with the string hello world. And we'll then call that function. And if we get any errors out of this, we want to panic and print the error. Otherwise, it's all succeeded and we're probably good. All right, we'll now be able to run the first demo. Or so I thought. We should probably return the JavaScript object here, or the Goja object. Sorry for that. All right, so we now execute JavaScript inside our Go application, and we managed to print a hello world message. Awesome. Let's see. But one thing to keep in mind here when we do this, as you saw, I actually created my own implementation of the console object, which only had one method, log. I mean, Goja is a separate runtime. It doesn't implement the features that NodeJS has, or even most of the features that a browser has. It has all of the language constructs and all of the things included in at least ECMAScript 5.1, but it does not have, for instance, require or the FS package or whatever else you might be used to from the Node.js world. Because Goja is not Node.js, as I said. It's not, and nor is it V8. It's a standalone implementation, and it's written purely in Go. And this makes it extremely performant, mainly due to how Go routines work. But it also lacks a lot of the features. As I said, we don't even have an event loop in Goja from the get-go. So you'll either have to do as I did and provide them yourself as features or as modules that you can import, or you'd have to find someone else that already made that implementation and depend on them. And let's do another demo where we implement a naive proof of concept version of the require function so that we get some kind of module handling implementation in our JS runtime. And for this, I've already gone ahead and moved the console implementation with it to its own package, just so that we don't have to redo that. But we'll go ahead and start by creating a module that we actually want to be able to use in our Go application. And for the sake of the demo, we're going to do a real easy one. So we'll call it just event. And we'll define a module that we'll use for this. And we'll also add a factory method for that, or function for that as well, so we can create new modules. And it will just return a pointer to a new module. And we'll add a function to that as well. And this case, let's call it getName, and it will return, or rather, yeah, it will return a string which will set to Go online Go Conference 2021. So we now have another module, just as the console one we did earlier, that just gives us the name of the event that we're currently at. Very naive, but it will do the job for the sake of this demo. And we'll also create the module resolve, since we want to use that, or rather we'll create the file resolve, since we want to use that to be able to actually access this event file or event module. So in resolve.go, or rather, sorry, that's my bad, require, for sure, of course. We'll add the package declaration, and we'll go ahead and import Goja just as we did previously, as well as the module we just wrote, which we want to make available through the require method. And we'll then create a factory function for this as well. Which returns a function that returns a Goja value. And here we'll set up a map of the modules that we've implemented and want to make available to the user. And in this case, we've only implemented one module, which is called event. So requiring an event will create a new instance or a new struct of the event module. And we'll then return the actual function. And if the module the user is requesting does not exist, or rather, if it does exist, we'll return it. Otherwise, we'll return null or nil. All right, so we created the require function and we created the event module. And we'll now set up our application to actually be able to use this. So same as previously. And we'll add the console import as well, and our require file or package. And then in the main function, we'll once again create a new Goja VM, and we'll also add a field name mapper, which will make sure that our modules and our functions and everything gets lowercased. So it looks like it would in a regular JavaScript environment. And we'll create a new console struct, and we'll assign that again, as well as the require function. And then we're gonna go ahead and run this again. So we have our say hello function yet again. And this time we're gonna require the event module. And then do another log. Okay, so let's run this. And hope I've not made any spelling mistakes this time. Which I, of course, did. Or rather, a brain fart. Let's see. We can't have two modules, of course, in the same folder, so we're going to move that into require. Let's try again. Hello, online Go conference. Awesome. So now we have a module resolution in place. And that took us what, like 5 minutes, 10 minutes maybe tops to do all of that. So imagine if you were to spend some time with this and actually implement wrappers or interfaces for your users to be able to script in JavaScript and just put together the workflow of their application themselves based on what you've provided as building blocks. Now let me switch back to the presentation again. And as I said, with this, we'll now be able to extend the runtime with modules that the user would be able to load using the require function, just as they would with regular Node.js code. So for instance, if we, as in our case, have an application called K6, then we could add K6 modules that lets the user import various pieces of our functionality and use them in a way they see fit. But keep in mind that this solution is just an embryo, lacking most of the node module resolution algorithm that you would see in a real Node.js environment. It works for this simple case, but it wouldn't work with, for instance, packages that you've installed with npm, of course. So if you were to do a real implementation, that would probably take quite a bit more effort. And to ease this effort, the author of Goja, DOP251, also created a extension project called Goja Node.js, which adds a couple of additional Node.js features. We may use this to make the experience a little bit closer to what you would expect from regular Node.js. In K6, we've not been able to use it for various reasons, but for most, this should probably be an excellent boilerplate to extend on. It requires, for instance, the console that we implemented naively require it. It contains also some utils as well as a rudimentary event loop that you can use for asynchronous scripting as well. And so to summarize, Go is a great language for high concurrency software. It lacks a lot of the runtime flexibility provided by scripting languages, though, and we may, to some degree, alleviate this by embedding a scripting layer in our application. And there are a lot of considerations to take into account when deciding on what scripting language to embed or even what flavor of that language. One size certainly won't fit all in this case. For us, JavaScript and Goja was the right approach, but for you, maybe Python is a better approach. So you'll have to experiment. But luckily, all of these projects are quite easy to integrate into your application. So you probably have the time you probably can afford to try out a couple till you find something that you like. Personally, I come from a JavaScript background and then got into Go much later in my career. So for me, it's really, really nice to be able to combine both of those. And it makes it really, really compelling for me to use Goja. And last but not least, we've also done 2 demos where we showed how to get started with Goja and how easy it is to get something up and running. And that really concludes my session. So thank you so much for having me.